This movie highlights NX sheet metal modeling capabilities. It is based around a child's bicycle seat and the sheet metal bracket that holds the plastic seat to the tubular frame. The designer has already created the initial base solid for the bracket, and you can see references of the surrounding geometry, shown here in blue. The bracket is symmetrical, so the designer will only need to model one half and use the final mirror operation to complete the design. This increases design efficiency and speeds up the product design time. The designer will now start to add more sheet metal features to this base flange. The first to be added is another flange. Notice the dynamic preview of the flange and the drag handles. The design engineer can make real-time changes during the creation process and get immediate feedback. In order for the bracket to fit correctly, the design engineer needs to directly reference the surrounding geometry. The flange is based on a sketched profile, so the designer has all the powerful sketch editing tools at his disposal to make the necessary shape change. You can see that there is still an issue with this flange. Although it is reflecting the profile needed, there is a clearance problem. In this situation, the designer again references the surrounding geometry whilst creating a jog. You are seeing how quickly and easily this task is accomplished. The designer continues to design in context and illustrates how easy it is to construct sheet metal features whilst considering the surrounding parts and also using design logic to capture design intent. In this case, using a measurement to define the height of a jog. Design logic is an enabler for knowledge capture and reuse. It allows you to use CAD external information directly in the design process, use mathematical functions and formulas, or, as in this case, is used to interactively create an associative measure you can use to accurately define the jog height. Simply put, design logic facilitates design capture and reuse and has a positive impact on design efficiency and product quality. There are situations when different construction techniques are required, and here you will see that the designer uses a sketched profile to create a more complex flange section easily. The designer can quickly draw the profile and then add design rules relative to the tubular frame. NX then creates the flange based upon inputs from the designer with respect to the width and type of relief. The designer now uses more NX sheet metal features to complete the design, all in context of the assembly. You can see that we will sketch the flange profile and utilize the reference geometry to assist in defining and controlling the section. This is key in ensuring the bracket matches the design intent. You might well see an alert appear stating that the preview has failed. This is fine and good feedback. In this case, the direction of the flange width is incorrect. It is easy to remedy this by reversing the direction. The final tab will now be added to the fixture holes created. Again, the reference geometry will be used to assist the creation of these. To make sure of a good fit, the tab created needs to be modified and a bend added. This can be easily added retrospectively. Finally, the reference geometry is used to create the fixing holes before we mirror the geometry and complete the bracket design. In summary, what you have seen is that NX can create sheet metal parts easily in the context of an assembly. NX has powerful sheet metal features which enable the design engineer to fully construct sheet metal parts while referencing surrounding geometry.